Hello CS111 students, this is my problem set explainer video for problem set 5 task 4 on poetic structures. And this task is really about nested list structures and nested loops for dealing with them. Although in certain places in the task you'll only need singular loops. So think about how to put loops inside of loops, why you might want to do that, and this task will force you to do that a little bit. Do check the rubric for the different requirements of the different functions and which ones in particular require a loop within a loop. There are 4 parts of this task. Part A, B, C, D. Part A is kind of a warm-up. It is a function that determines whether or not a word is just punctuation, because the way that we store words in this task is a little bit interesting. If you have already done problem set 1 task or problem set 5 task 1 on wordplay, you'll notice that we had a word counting function that you had to do for that. And that word counting function was given a big block of text and was required to count the individual words in that block of text. And it got a little bit complicated with the way that words were defined there. In this task, we store a poem as a list of lists of strings. So you could imagine storing a poem as simply a string, right? It's just text. You type out your text and you have your line breaks for when the poem has multiple lines, and maybe you have some blank lines for when there are multiple stanzas. But that representation makes it difficult for the computer to know things like which parts of this text are different words. And so in this task, we have a representation of a poem as a list of lists of strings. The strings are words, individual words one at a time in a single string. They are joined into lists that represent individual lines of the poem. And then those lines of the poem are joined into a larger list that represents an entire poem with multiple lines. Some of them could be blank if you have gaps between stanzas of the poem. And those blank lines would be represented by an empty list, a line of the poem that does not contain any words. So there's a poem structure.py file that you can use to get started with this task. We've supplied various kinds of supporting code in that file. And so I've gone over this representation part a little bit. Here's a specific example in the website description. There's a famous Chinese poem that has been translated here that reads, "Goose, goose, goose, sing to the sky with necks incurving, white feathers afloat on verdant waters, orange palmate feet push the clear water." It actually sounds much better in Chinese. And we have a version of it in Chinese in a file called poems.py, along with several other poems in different languages and in translation. And there's a note in the problem set. If you have a favorite poem that you'd like us to include for future iterations of this problem set, we would love to hear from you. But this poem, right, that has been translated into English, we have an example in the problem set of the Python representation of this poem as a list of strings. So it is a list. You can tell that by the square brackets at the beginning and very end of this. And then it includes 4 different lists, one for each line of the poem. The first line of the poem has actually 5 strings in it. And this is where things get complicated. The first is the string goose, because the first line of the poem reads goose, goose, goose. But it doesn't just read goose, goose, goose. It has commas in between. Goose, comma, goose, comma, goose. And to help us with our analysis and or make our lives more complicated, punctuation is represented as its own so-called word within this format. So the first list in our list of lists for this poem is the string goose with a capital G, then the string containing a comma and a space, then the string goose with a lowercase g, then another string containing a comma and a space, another string goose with a lowercase g, and that is the end of the first line of the poem. That is our list of 5 strings: goose, comma, space, goose, comma, space, goose. Okay. Um, Throughout the poem, you'll see the same thing happening where individual words are simply represented as strings. When there is punctuation that happens between words, we have an extra word for that. So the period at the end of the second line of the poem after incurving is just its own thing. And because punctuation might need a space after it, for example, a comma might need a space after, or before it, for example, an open parenthesis or quote might need a space before it. Um, the punctuation strings include spaces in them, um, but if there's no punctuation between two words, then we just assume there's a single space between those words in the poem. So this is our representation of a poem, and what we're going to be doing is writing some code to analyze the syllable structure of these poems. So given a poem, we're going to go through the words, try to estimate how many syllables are in those words, and then we will print out a summary of those, of basically how many syllables are in each line of the poem. So for the Goose, Goose, Goose poem, um, we would say that there are 3 syllables in the first line. By the counting that we use, and we have given you a function to count syllables in a word because that's a complicated task in and of itself. But by the function that we use, there are 9 syllables in the second line and 10 in each of the third and fourth lines of this poem. So one of the tasks you have is to take a poem and spit back out a list of integers where each integer represents the number of syllables on a particular line of that poem. And then there's a way of printing these syllable structures using dashes, where we print number dash number dash number, but then if there's multiple stanzas, we would have those on different lines. So we could say that the poem above has a 3-9-10-10 structure, or that a traditional haiku would have a 5-7-5 structure typically. So there's one more, actually several more wrinkles to this, but one of those additional wrinkles is that we have these poems in different languages. We know that lots of people in this class speak more than one language, and we figured that it would be interesting to have a sample of how a programming language like Python might deal with that. So we have some Chinese and some Japanese and some Spanish and some Scots even in our poems.py file. And we have multiple versions of the same poem that are stored together, right? So we have this English version of this poem about geese, and we also have the Chinese version. And so when we have multiple versions of a poem, the way that we're storing that is in a dictionary. Now, dictionaries are a topic that we are mostly going to cover next week. So we're not really diving all the way into dictionaries for this problem set. We're just asking you to use a few different, very simple dictionary features. We are giving you these poems as a dictionary where the keys of that dictionary are languages, which are strings like the word English with a capital E or Mandarin with a capital M. And the values for those strings are these poem values, which are lists of strings, right? So the whole thing is a dictionary that maps strings to lists of strings, and like we're getting into really complicated data structures. But we have also given you some code that extracts those poems from their dictionaries and can do the testing for you without you having to worry about how to get the poems out of the dictionaries. So you don't necessarily have to worry about that wrinkle. However, there are some other wrinkles in the handling of languages that you are going to have to worry about and use some dictionaries for, which we'll get to in a second. Okay, so this is all background material. As I mentioned, there's an estimate syllables function. One of the wrinkles that I just mentioned, though, is that we have these different languages, and estimating syllables works very differently in different languages. So the estimate syllables function requires you to give it a language parameter that will tell it which language to use to estimate syllables, right? If you're estimating the syllables of an English word, that might be a different number of syllables than the exact same sequence of letters in Spanish, because of the different way that letters are treated in those languages and the different pronunciation rules. Um, so we have provided in the poemstructure.py starter file a dictionary called language modes. It's in all caps because it's a global variable. And it contains a mapping from language names like English to what I call syllable estimation modes, which are just strings that tell the estimate syllables function how to estimate syllables. So you can't give estimate syllables a language English. You give it a estimation mode, which is a different kind of string. And the language modes dictionary will tell you, well, for the language English, here's the string that we use to estimate, the mode that we use to estimate syllables in that language. That's because there are different languages, like, say, English and Scots, that use basically the same mode for estimating syllables. So you should look at that estimated syllables function. And one of your jobs in this task is to figure out, okay, how do I supply it with the correct parameters so that it can do its job? You don't need to know all the details of how it works necessarily or understand them. But you should look at its docstring to understand, okay, what values can I give to this function and how can I get those values? All right. Finally, let's get into part A. The very first part of this task is a function called isPunctuation. As I already mentioned, we want to separate out those punctuation words because we're going to treat them differently than other words. And isPunctuation is going to be a predicate that helps us in that task. You give it a word, which might not actually be a word, it might just be a string containing like a comma and a space, and it tells you yes or no, is this so-called word entirely punctuation or not? So, our definition of what a punctuation word is as follows. First, we've given you a global variable that we've named punctuation in all caps. That contains a string with a bunch of punctuation marks in it. It's not every possible punctuation mark, and this is a kind of imperfect approach, but it does contain all the punctuation marks we've used in the poems we've supplied. So a word counts as a punctuation word if every single letter in that word is either one of the punctuation marks or a white space character. And there's a method of strings called isSpace that will return true if the string before the period is made entirely of white space. Or you could use it on a string containing just a single character to say, hey, is this character a white space character or not? A wrinkle here is what to do if the word that we give you is an empty string. In that case, isPunctuation should return true. And that might not make sense because you're like, well, the empty string isn't really punctuation, is it? But neither is the empty string a real word. And in this case, if we wanted to have two separate words in our poem, but we didn't want a space to appear between them, we could put an empty string between them. It would be counted as punctuation, and then those two words would appear right next to each other. So, if you want full credit for this task, you should use an early return pattern. You do have to use a for loop to do this. And we've provided just a few examples of how this should work. So if you give it a word like hello, right, which has some characters in there that aren't punctuation, then it should return false. But if you give it a dash, it should return true. If you give it a comma and a space, it should return true. You can think of, and you should, extra tests to add to our test function, where these tests appear in the file as well, to test other things that might happen, right? Like, what if there's a combination of punctuation characters and non-punctuation characters? That should return false because it's only a punctuation word if it's all white space or punctuation characters. Okay, that's part A. Just requires a single loop, no double loops yet. Part B is count syllables. So we'd like to know the syllable structure of the poem. As we had talked about before, the syllable structure is a list of numbers where each number represents a number of syllables that appear on a particular line of a poem. So count syllables should take in a poem, and not just a poem in multiple languages, but a poem in a specific language. So for example, um, a list of strings. It has a second parameter to specify what language that poem is in. And its job is to apply the estimate syllables function to every word in that poem. And for every line of the poem, the sum of the estimate syllables results for each word in that line should be returned as an integer as part of a list of one integer per line of the poem. As I mentioned before, you're going to need to use that language modes dictionary to take the language of the poem and turn it into an estimation mode for estimating syllables. Um, there's some examples of how this should work. So here we have a poem in Japanese, um, and it is, so we've called the count syllables function with 2 arguments. I've split it across a bunch of lines to make it clear what's happening. The first argument is a list, and it starts with a square bracket and ends with a square bracket right before this comma. The list contains 3 smaller lists. The first list has 2 words in it, samidare and ni. And then the second list has 3 words, tsuru, no, and ashi. And then the third list has 2 words, mijikaku and nareri. This is a famous poem by the famous poet Basho. So this poem is in Japanese, and as the second parameter to count syllables, I've provided the string Japanese. With those 2 arguments provided, the result that we get should be the list containing the integer 5, the integer 5, the integer 7. So a list 5, 5, 7. Because at least in this way of writing Japanese, counting syllables is incredibly simple. Every single character is a single syllable. So we can count on the first line of this poem 1, 2, 3, 4, 5 syllables between the 2 words, right? We're adding up the syllables for all the words in a line. So the first line has 5 syllables. The second line, tsuru, no, ashi, is a total of 5 syllables. And then the last line has 7. Mijikaku and nareri is 4 plus 3 is 7. So we give it a poem and a language, and it spits out, hey, here's a list of syllable counts for each line of that poem. Here is the same poem translated into English. So in Summer Rains, that's the first line of the poem. Second line, the crane's legs. Third line, become short. Here, this time the language is English, and so we're going to apply a different estimation mode to estimate the number of syllables in each word. And again, these estimates aren't always 1,000% accurate, but just use estimate syllables and trust the results. So in this case, we get 4 syllables, 4 syllables, 3 syllables. In summer rains, that's 4 syllables. I think the estimation is pretty accurate there. The crane's legs, I might have counted that as 3 syllables, but I think the estimation is looking at cranes and seeing the A and the E as 2 vowels and not realizing that crane, the E is an ending E, so we shouldn't count it, and even with an apostrophe S, it doesn't really add a full syllable. So it counts that as 4, and we should just use 4 for that number. And then become short, 3 syllables. So 4, 4, 3 syllables in English, different structure. Okay. We've given you several examples of how count syllables should work. Your job is to make it work that way. Now, do note that punctuation words detected by that is punctuation function, right, should not be given to estimate syllables. They don't count as any syllables at all. We should just skip them. So this is a function where you should have a double for loop, right? And you should think about, why do we need a double for loop for this function? And what's the purpose of that? Okay. Part C is show syllable structure. And this part is going to take the output of the previous part, where it's a list of syllables, and it's just going to print it out in a way that sort of makes sense. This one does not necessarily require a double for loop anymore. So show syllable structure is a non-fruitful function. It prints stuff, but it does not return a value. And it takes one parameter, which is a list of integers, where those integers are representing syllables per line in a poem. um, although they don't necessarily have to. What it does is it prints out all the integers it got, separated by dashes, with the extra wrinkle that if there are any zeros in that list of integers, then for each of those zeros, it splits the output into multiple lines of output. So if it got the list 1, 2, 0, 1, 2, 5 numbers, since there's a 0 in there, it would print 1 dash 2, and then new line, on a separate line, it would print 1 dash 2 again. We've given you some examples of what it should do. It's a little bit simpler than the previous function. But that will allow us to sort of more quickly read the syllable structure of a poem to, say, compare the syllable structures of two different poems, if that's something you're interested in doing. Final part of this task is part D. And part D is the probably most difficult task. It has the most sort of little details to think about. And it's called display poem. So I mentioned at the very beginning of this video that you could represent a poem as a single piece of text, just as a string, right? And that piece of text would have a bunch of spaces and punctuation marks in it, and it would be harder to estimate syllables in that text because you'd have to do this task of trying to remove punctuation and trying to split up words that sometimes is ambiguous. So we've represented these poems as lists of words with all these wrinkles to make that task easier. But it's harder to read these poems as a list of strings, right? Somebody who's not used to Python would be like, what's going on with all these brackets? I don't understand this. So the goal of display poem is it's a non-fruitful function. It takes two parameters. Number one is a poem, a list of words, and number two is a string, which is the language that the poem is in. Same parameters that count syllables took. This function is going to simply print out the poem, right? Displaying it to the user. But it has to obey the conventions of the language. So in some languages, we use spaces to separate words from each other. Other languages just don't do that. And so there's a language spaces variable provided in the starter file that is, again, a dictionary. The keys of that dictionary are languages, just like the parameter that display poem gets. And the values are true or false. They're Boolean values. If it's a true in language spaces, that means that that language should have spaces between words. If it's a false, that language does not need spaces between words. Your display poem function has to work for both languages that use spaces and languages that don't. If you are printing a poem that doesn't use spaces, then your job is pretty simple. Just take each word on each line of the poem and mash them together and print them out, right? And print each line of the poem on its own line. If a poem has an empty list in it representing an empty line, you should print a blank line there to separate stanzas of the poem. If you're in a language that does use spaces, then you also have to insert spaces between each pair of words in the poem. But you shouldn't have any extra spaces before the first word of a line or after the last word of a line. And you also don't insert any extra spaces between words and punctuation words. And this is where our friend is punctuation comes back to help us out, that predicate that we wrote at the beginning to decide if a word is a punctuation word. Right? Those punctuation words already have spaces in them where they need them, like comma space or space parenthesis. And so they should just be joined together with the words on either side of them without anything in between. Whereas other words, if there's two words that aren't punctuation words in a row, we should put a space in there, assuming the language uses spaces. Okay, there is a note here. In some cases, your computer may not be set up to display all the characters from the poems.py file, especially the poems that are in languages other than English and or in alphabets other than the Latin alphabet. If that happens to be you, which should be pretty rare these days, but does happen, we have provided a special poem called Variables, which is in a made-up language called Variable Names that doesn't use spaces, because all the other languages that don't use spaces in that file use East Asian glyphs that you might or might not be able to display. So you can use the variables poem to test whether your function works for languages that don't use spaces if the other things in that file are not displaying properly for you. Okay, so we've given some examples of what the display poem function should look like in terms of its output. Um, and I'm not going to go into them here. Um, the variable names poem here you can see is an example of how spaces don't get used between words. Um, that is it for this task. Um, there are quite a few different wrinkles to figure out in display poem. And feel free to ask questions on Piazza if you have questions about the details there or things that aren't clear. Um, but it's a little bit of a more complicated task. Um, there's different ways to approach it. I think it is naturally suited to a double for loop, which is again the theme of this problem set. Um, and it's worth thinking about your approach before diving into the code. Okay, that is the end of this video and the last problem set explainer video for this problem set.